Hi everyone, thanks for joining again. This is going to be a quick demonstration of how you could count the number of part properties that you may have that a certain part of your system is utilizing, and you're doing that based off the multiplicity, so you may want to actually pull that value into some other equation where you're calculating how many you have of something. So notice we have this multiplicity here of 9, which means there are actually 9 of these blocks that are parts that are defined by this part definition block. So what we'd like to do is actually pull that into a simulation and see that output. That way we could use that as an input for something else. So the way to do that is by using a constraint, and this simply says part count equals len of x, or length of x, and that is a simple Python or Jython script. So if you look into the specification here, you'll notice that the language is set to Python, but that could be Jython as well, and that will work just fine. An important thing to note is that the part count parameter here is an integer. That could be also a real number, and then the parameter for x, which we are counting the length of, needs to be defined by or typed by this same block here, so part definition. So that's very important, and then also the important multiplicity that we have here. So those two things together, and then notice what I did was dragged this constraint onto that system block, and that's how it added this constraint as a constraint property of that system block. And then when you create the parametric inside of this block, what you can do is pull that in. So if we were to rerun the simulation, you notice it simply kicks out that value for the multiplicity there, which is exactly what we wanted. And if that were to change, maybe let's say we change that to some other value, you'll see that when you rerun that simulation, that'll be reflected in the output. And then that is slightly different from if you were to attempt to do something like this where you query your model and pull all of those values into a table. When it comes to queries in particular, you cannot use derived properties in simulations. So that's where it becomes useful to do something like this if you actually needed to use that value in a simulation. So that's a simple example, and that's a pretty straightforward solution for that. I want to thank Alex Whittier for that solution. He was the one who came up with that idea, and he had used that for some type of a trade study he was doing. So let me know if you guys have any other ideas for how you may use that. Thanks.